Good morning everyone. Welcome back to VKP Online Tutorials. Today we will discuss the problems on traveling salesman problem. It is also known as routine problem. Let us take this problem. Solve the following traveling salesman problem and is given the from and to places, or we can say from route and to route is given. The route A to B, we need to spend cost 2 rupees, and again if you want to move from route A to C, we need to spend 5 rupees. So like that the cost matrix table is given. So we need to determine the optimum route or best route and the corresponding optimum cost for the traveling salesman problem. So let us see how to solve this problem. So before solving traveling salesman problem, you should aware about Hungarian method. How to apply Hungarian method for the given traveling salesman problem. So we need to apply row reduction, then we need to apply column reduction, then we need to go for allocations. Suppose if you are not getting optimum solution after allocation, so we need to go for reallocation. Let us see how to apply these conditions for the given cost matrix. So now I will apply row reduction. In row reduction, in a row wise, first identify the least element in the first row. This is my first row, and the least element is 1. So I will subtract the other elements with 1 in this particular row. Okay, let us take this is infinite. I will not consider the diagonal element. Next is 2 minus 1, so that is 1. The least element is 1, so I will subtract the other elements by 1. So now it is 2 minus 1 is 1, 5 minus 1 is 4, 7 minus 1 is 6, 1 minus 1 is 0. Similarly, for the second row, look at the second row. In the second row, the least element is 2, so I will subtract other elements with 2 in this particular row. The 6 minus 2 is 4, and diagonal element I will not consider diagonal element. 3 minus 2 is 1, and next one is we have 8 minus 2 is 6, 2 minus 2 is 0. Similarly, I'll go to the third row. This is my third row. The least element is 4, so we need to subtract other elements by 4. So 8 minus 4 is 4. Then we have 7 minus 4 is 3. Diagonal elements I will not consider, infinite. 4 minus 4 is 0. Then 7 minus 4 is again 3. Similarly, I'll go to the next row. This is my next row. The least element is 4. I will subtract other elements by 4. So it's 12 minus 4 is 8. 4 minus 4 is 0. 6 minus 4 is 2. Diagonal elements I will not consider the diagonal element. 5 minus 4 is 1. Now I'll go to the next row, last row. The least element is my last row. The least element is 1. So we need to subtract other elements with 1. So this 1 minus 1 is 0. 3 minus 1 is 2. 2 minus 1 is 1. 8 minus 1 is 7, and diagonal element I will not consider. This is the row reduction. Next, we need to go for column reduction. Let us see what is column reduction. Now look at the column, first column. This is my first column. The least element is 0, so we need to subtract the other elements in the same column by 0. So this is infinite. I will not consider the diagonal elements. Then 4 minus 0 is 4, 4 minus 0 is 4, 8 minus 0 is 8, 0 minus 0 is 0. Go to the next column, second column. This is my second column. The least element is 0, so we need to subtract from 0. 1 minus 0 is 1. 3 minus 0 is 3. 0 minus 0 is 0. 2 minus 0 is 2. Similarly, I will go to the third column. 1 will be the least element, so we need to subtract from 1. 4 minus 1 is 3. 1 minus 1 is 0. Diagonal element I will not consider. 2 minus 1 is 1. 1 minus 1 is 0. Next, I'll go to the fourth column. Least element is 0, so we need to subtract. 6 minus 0 is 0. 6. 6 minus 0 is 6. 0 minus 0 is 0. Diagonal elements I will not consider. 7 minus 0 is 7. So in the next column, least element is 0, so we need to subtract from 0. 0 minus 0 is 0. 0 minus 0. 3 minus 0. 1 minus 0. And diagonal elements. I applied column reduction. Next step is I'll go to the allocation. Identify a single 0 in a particular row and allocate that 0 and cancel the corresponding column. So now look at the first row, we have single 0. I allocate this 0. So now I allocate this 0. This is my allocation, and I'll cancel the corresponding column. So my corresponding column is, this is my corresponding column. I'll cancel this column. Now go to the next row. This is my second row. In the second row we have single 0. I allocate this 0 and I will cancel the corresponding column. This is a single 0 in the second column. I will cancel the corresponding column. So this will be the corresponding column for this 0. Next, I'll go to the third row. Look at the third row. You have 4, 3, and 0. So you have single 0. I'll allocate this single 0 and I'll cancel the corresponding column. I'll allocate this 0 and I will cancel the corresponding column. This is my corresponding column. Go to the fourth row. This is my fourth row. In fourth row we have 8 and 0. I have single 0 in the fourth row. I will allocate this 0 and I'll cancel the corresponding column. So my corresponding column is, this is my corresponding column. I'll cancel the corresponding column. Next, go to the fourth row. In the fourth row, sorry, in the last row, you have only one element, single 0. I will allocate this 0 and I will cancel the corresponding column. This is my corresponding column. I will cancel the corresponding column. Okay. Now Look at the number of allocations. So we have number of allocations are 1, 2, 3, 4, and 5. There are 5 number of allocations. So what is the size of the matrix? So size of the matrix is 5. Therefore, the solution is optimum. Solution is optimum. So now I write a comment. Since the number of allocations equal to size of matrix, therefore the solution is optimum. Solution optimum in case of assignment. So now we need to cross check whether we will get optimum route or not, or whether the obtained route will satisfy the conditions of traveling salesman problem. Let us see this case. So now the routes are here A to E. I will take A to E, you will travel, and E to A, again you will come back to A. Here A to E, that's the one route. You will travel from A to E place. Again from E to again you will come back to A without move to location B. Without move to location B or C or D, you will come back to its initial position, that is the start point, that is A. Therefore, this is it will not obey traveling salesman problem. So how to find the optimum traveling salesman problem? To find this optimum traveling salesman problem, identify the least element. Identify the least element in the cost matrix table. So in this cost matrix table, the least element is 1 will be the least element. Okay, so now I allocate for the 1 and I will provide a new route in such a way that to obtain the optimum solution. Let us see what is that. See now the next my new allocation is the A2. Here I will not allocate for 0 because if you allocate 0, you will not get, it will not obey traveling salesman problem. So I'll pick the least elements. I will allocate A and E. I will allocate 1, then I'll write a new route. Say from A to E, sorry, A to B, A to B, from A to B, and where is B? The B to C, because there is no small element 1 in second row. I allocate C, A to B to C, and where is C? C to D, fine. C to D, and D to B. I will not allocate B because we have. If you allocate B again, you will come back. You will come back to location B without reaching location E. So now I allocate least element. Least element is 1. So I'll write D to C. D to C. Least one is C. Then what is C? C to D. Even C is also not possible because we already again it will not obey traveling salesman problem. If you allocate D to C, instead of here I will allocate E, D to E. Next least element is 1. You have one more option E here. I allocate E. Then E to A. E to A. So this is the possible optimum route for the given traveling salesman problem. So this is the optimum route. This is the optimum route for the given traveling salesman problem, and we can calculate what will be the cost. Therefore, optimum cost is optimum cost. I will write optimum cost. See A to B. Just look at the original cost matrix. A to B is rupees 2. Then B to C. So B to C is rupees 3. Then C to D. C to D is rupees 4. And D to E. So D to E rupees 5. And last one is E to A. So E to A is rupees 1. So the optimum cost is 13 rupees. 5 plus 5 times optimum cost is 5 plus 4 plus 1, 3 plus 2. So that is rupees 15 will be the optimum cost. So this is the optimum route. This is the optimum route, and this will be the optimum cost. So this is a very important problem. Thank you, and thank you so much.